Hey everybody, my name is Chris Helm and I wanted to walk you through the work we did last week for the Spatio-Temporal Asset Catalog Sprint number 6. What we did was take a huge repository of point clouds and generate a STAC catalog from them. Now, the focus of the sprint was a software sprint, not a data sprint. So what we wanted to do was drive home and make some progress on getting more support for point clouds into the STAC ecosystem. Using the USGS 3DEP Entwine repository hosted on Amazon, or AWS, I should say. And what we want to do is take each of these Entwine datasets and generate an item in a STAC catalog. Now, this serves our purpose at Pixelate Earth because we want to search and access this data on the fly because this is crucial for our geo-registration process, but we wanted to really just get more involved as we progress our data into STAC and work on STAC, like make sure that the groundwork is being laid for things like point clouds. Now, if we look at one of these point clouds, they're point clouds. They're data sets. They're massive when taken as a single entity. But one thing that EPT and Entwine allow us to do is load them dynamically. So even though my connection's being a little slow right now, what we can see when we zoom in on some of these data sets is they load dynamically. They bring in only the data you need to see when you need to see it, which is pretty nice. So then, all right, so where to start? We started with looking at the work that others had previously done defining an extension. So we saw this and said, oh, this is great. We can start here. This tells us everything we need to have in order to create a STAC item that can be searched and accessed. Things like the count, the type, the encoding. I think there's a little bit more work that needs to be done here around like some just defining some of these things, like what phonology means, but maybe that's just me, or being new to STAC. So taking this extension and wanting to write some software that makes it easier for us, ourselves, in a Python environment to generate the items dynamically without just writing a bunch of JSON ourselves. So we went to PyStack and we looked at PyStack. It already has support for extensions. So we went ahead and basically took sort of the boilerplate extension and created a point cloud extension for it. So here we really just defined the getters and setters on different types of information that we want to attach for this extension to be valid. We go ahead and write it out, we tested it, we added docs, did all the things, and that was really our main push, is just getting this PR'd onto the main PyStack repo. But then thinking about, okay, now that we've got this extension, how do we drive it? How do we generate our catalog? Well, we look at our USGS LiDAR boundaries, right? So this is kind of this ever-updating GeoJSON of all the bounds of this LiDAR data capture. What we can do is we can fetch each of these boundaries and get access to the underlying EPT data, things like counts and dates and names and stats. So what we do is we drive that via a PyStack notebook. And here you see that we create a catalog, the standard stuff, just generate a catalog, think about where we're going to host it, which is on S3. Then we fetch our boundaries, loop over the boundaries, and generate our items, right? So for each item, we create it with our bounding box and our geometry and a name and description and all that stuff. And then we get to the meat of what we're trying to do here, and that's just enable the point cloud extension, give it everything that makes it a quote-unquote point cloud, and then assign the assets to that item, build up our big list of items on our catalog, and then dump everything out to disk. Super simple stuff because that's what is awesome about PyStack, right? It makes it really easy just to generate these conforming documents. Things that need to be done still on this is before we index this or say it's like a public resource that should be used, is I think just capture more information, more things like dates. Right now the date I'm using is just the date at which I scraped the catalog. I think the date times need to reflect when the data were captured. The other thing that needs to be done is using Poodle to capture statistics for each field, which may or may not involve fetching the entire thing, which would maybe be prohibitive for this sort of thing. So we'll see about that. And then also in future sprints or future work, I'm really interested in thinking about ways to keep these static things, these static catalogs sort of up to date with changing resources on the back end. And I know that there's been some work done in other catalogs around S3 and SQS and SNS and keeping them up to date and triggers and whatnot. But I think exploring GitHub Actions would be really, really cool, because what we're dealing with here is a single entity, a single resource that lives in GitHub that could be bound to via an action, and then a new item appears or something happens and kind of acts like a cron job, right? And then produces new records, puts them in. Anyway, that would be cool. But if we look at the data now, so here's our catalog. Super exciting, right? It's very straightforward and pretty simple. We can click on one of these and see that it's got all the data we expect, count, type, encoding schemas, and voila, it's a STAC catalog. If we go and look at my localhost running this catalog, and I just click on a random one, and for some reason I need to refresh to get the item to appear, but the item appears. You can see it's in Arkansas, I guess, but it's kind of boring, right? There's really nothing too exciting about this. So I think, as Chris Holmes mentioned in a tweet, I think it was just about making this more compelling, making this more interesting. Like, there's no reason we couldn't embed a viewer here. There's plenty of CoinCloud viewers, plenty of EPT and Twine viewers as well, that would allow us to actually explore it here. Just like a COG could be explored on the web these days. These point clouds can be streamed, and it should be pretty cool. Make this page a little bit more exciting, I should say. So then in future work, in a couple weeks, there's a data sprint, I think, right? And that data sprint, we're hoping to sort of work with some Pixel 8 Earth data. What we're doing is basically building a bunch of point clouds, right? And these point clouds are geolocated and referenced, and we're building these little mini worlds. And as we build these little mini worlds, it's pretty crucial and important that they have time and space attached to them. And so each of these small little point clouds here, right, they're individual clouds that we can kind of visualize and view. And each of these clouds is really a publicly available tiny little asset, right, that can be used by someone. And so I think what we're going to try to get into is more about the STAC server capabilities, and having our server produce something like an API that produces these out. Maybe we can do that as part of the data sprint. I know it's kind of backwards though. It's kind of like our data sprint is like a software sprint, and our software sprint is kind of like a data sprint. But anyway, hope you enjoyed. Thanks. Any questions, reach out. I'll keep working on this, on the catalog, probably try to get it up and then share it out more publicly and broadly and all that fun stuff. Thanks.